Hello and welcome. Today's session is going to be about rational expressions. So what I will be talking about is introduction to rational expressions involving evaluating rational expressions, the domain and range of a rational expression. I'll probably focus only on the domain here. And then also how to simplify rational expressions or reduce rational expressions. So I'm going to start with defining rational expressions. A rational expression is any expression that can be put in the form P over Q, where P and Q are polynomials and Q does not equal to 0. And as you can see from this definition, any polynomial divided by a polynomial is a rational expression. And notice that a rational expression looks like a fraction. So to remember what the word rational means, you probably want to think fractional. So rational is fractional. So when you deal with rational expressions, think that you're dealing with a fraction. And for any fraction that you can deal with, which looks like any of these expressions, 3x plus 5 over 2x minus 7, 1 over x plus 1, 2 over x squared plus 5x plus 7. Those are examples that the denominator of any fraction can never be 0. Remember, division by 0 is undefined. And so you have to be careful as you work with rational expressions that at no point the denominator will be 0. And so let's start with taking a simple rational expressions right here, 3x over x minus 4. And we want to evaluate this function. I probably should put here f of x equals. And so I want to evaluate this function for different values of x. So you could make x equals 0, and then your f of x value, remember f of x is the y value, will be f of 0. And to evaluate this function, so I'm going to say, it's not working very well. Okay, I'm going to say f of 0, that means the y value when x is 0, is 3 times 0 over 0 minus 4. So you're going to plug in 0 for any x that exists in this function. 3 times 0 is 0 over 0 minus 4 is negative 4. And remember, when you divide 0 by any number other than 0, your answer will be 0. So the value of this function is 0 when x is 0. So when you plug in 0 for x, the value of this function is 0. In other words, we can say, given this function, if x is 0, y is 0. That means if you graph it, 0, 0 will be on the graph. Or you could say that this graph is going to pass through the origin on the x and y coordinate plane. So again, f of 0 turned out to be 0. Now f of 10. F of 10 is going to be, going to take 3x, which is 3 times 10 over 10 minus 4. 3 times 10 is 30. 10 minus 4 is 6. 30 divided by 6 is 5. So we could say that f of 10 is equal to 5, which is equivalent to saying when x is 10, y is 5. And if you want to write this as an ordered pair, this could be written as 10, 5. So if you were graphing this function, 10, 5, x is 10, y is 5 will be a point on the graph. Now let's evaluate the function when x is negative 1. When x is negative 1, we're finding f of negative 1. f of negative 1 is going to be 3 times negative 1 over x, again, is negative 1 minus 4. So this is equal to 3 times negative 1 is negative 3. Negative 1 minus 4 is negative 5. And negative 3 divided by negative 5, remember, dividing a negative by a negative is a positive. So to simplify that is going to be 3/5. So we go back here and say f of negative 1 is 3/5. And then the last one we're going to evaluate is when x is 0. So we're trying to find f of 0. So we take 3 times. I thought we did that. Actually, I'm going to change that to f of 4. That's what I meant to have here, because we just did f of 0. F of 4 is 3 times 4 divided by 4 minus 4. 3 times 4 is 12 over 4 minus 4 is 0. Remember, for the rational expression to be defined, we can never have a denominator of 0. So when you get 0 in the denominator, that means the expression is undefined. So we can never find a real number x on the graph of this function. So the function is called to be undefined, or the rational expression is undefined.